Hello everyone. In this video, we will learn all about circles. A circle is a set of points whose distance from the fixed point is constant. Now, the standard equation of a circle is given as quantity x minus h quantity squared plus quantity y minus k quantity squared equals r squared, where it has two important properties. The center here is h and k, while the radius is basically r. So, for any circle, as long as you know the value of the center and its radius, identifying its standard equation is always possible. Now let's have an example. I have here a sketch circle. We will identify the center, the radius, and of course its equation. In this case, the center is 0, 0, while the radius from the center, which is the fixed point, going to one end of the circle, that would be 4. So therefore, the radius is 4. So in this case, the equation would be x squared plus y squared equals 4 squared, which is 16. Another example. Now in this case, the center is located at -2 and +1. Now the radius from A to B, that would be 1, 2, and 3. So therefore the radius is 3. So in this case, the equation would be, take note, it's -2, so therefore that would be x plus 2, then squared. Then the value for k is 1, so that would be y minus 1 squared is equal to 3 squared, which is 9. Now take note, center, rewriting it in the equation form, we will simply reverse its sign. So take note, -2, so +2 here. This is +1, so therefore here that would be -1. Now, another example. Now in this case, the standard equation is given. We will identify the center and the radius. Now in this case, the center is 0, 0, while the radius is the square root of 36, which is 6. Another example. Now in this case, for the center, take note, we will simply reverse the sign. So here we have -4 and here it's +6. So reversing it, we will have +4 and -6. While the radius, we will simply get the square root of 64, which is 8. Another example. Now this time it's reversed. The center and the radius, it's given. So we will rewrite this to standard form. So center 0, so that would be x squared. Take note that the k here is positive. So reversing it, that would be y minus k squared is equal to square root of 13. Squaring it, we will end up with 13. Now another example. This time, the center is 2, -3. And take note, here the diameter is 28. Now take note, diameter is times 2 of the radius. So in this case, since our diameter is 28, so therefore the radius here would be 14. So writing this in the equation, that would be x minus 2 squared plus, reverse this, y plus 3 squared is equal to 14 squared. 14, which is half of 28. Or we can simplify this to x minus 2 squared plus y plus 3 squared equals 196. Another example. In this case, the center is at the origin and the radius is 2. So, writing this or sketching this in the Cartesian plane, it's the center. So, the radius here would be 2. So, therefore, equation, that would be x squared plus y squared equals 2 squared or 4. Another example. So, -2 and 3, and the radius is 4. So, sketching this, -2, 3, it's located in the second quadrant. Now, -2 and 3. So, count radius of 4. So, sketch the circle. So, equation would be x plus 2 squared plus y minus 3 squared equals 4 squared or 16. Another. The center is at -1 and 3 and tangent to x-axis. So when you see -1 and 3, it's located in the second quadrant. So tangent to x-axis, so meaning it will touch the x-axis once. So take note, -1 and 3, and it should touch the x-axis once. So therefore, from A to B, then sketch the circle. So with this, our equation would be x plus 1 squared plus y minus 3 squared is equal to 9. Because from A going to B, that would be 3. So 3 squared will end up with 9. Another. The center is at 2, 4. Now 2, 4 is located at the first quadrant. So there are two circles here. So the radius of one circle is 2 and the radius of the second circle is 3. So with this, so that would be 1, 2, 1, 2, 3, 4. So the center is here. So radius of one is 2. So therefore we have 2. And the other one, the radius is 3. So that would be 1, 2, 3. So take note, there's two circles here. There are two circles with a common center. So equation of the first would be x minus 2 squared plus y minus 4 squared equals 4. The other one would be x minus 2 squared plus y minus 4 squared equals 9. And these two circles here, they are considered as concentric circles because they are two circles with the same center. Next. Now, equations of a circle can be expressed in two different ways. It could be in standard form, which is x minus h squared plus y minus k squared equals r squared. Or it could be in general form, in which it's denoted by x squared plus y squared plus dx plus ey plus f equals 0. So take note, when you say general form of a circle, coefficients of x squared and y squared should be equal. Otherwise, it's not a circle. Take note of that. So let's have an example. Let's convert standard equation to general form. So take note with this one. The center is at +3 and -2, while the radius is 4. So how to expand this to general form? So we will simply square the first binomial and the second binomial. And to do that, square the first, so x squared, multiply first, second, and 2, that would be -6x, and square -3, we will end up with 9. The other one, square the first, is y squared, multiply y, 2 and 2, that would be 4y, and square 2, we will end up with 4. Then 16 here, transferred to the left, would be -16. So at this point, we will simply combine terms or arrange them in descending order. So that would be x squared plus y squared minus 6x plus 4y, then 9 plus 4, that would be 13, then minus 16, that would be -3 equals 0. So therefore, this one is the general form of this given standard form. Now, what if we will reverse it? So we will have general to standard. So from here, we will reverse. So given this general form, we will reverse this to standard form. So to do that, first step, group all x terms, group all y terms, and transfer constant to the other side. So transferring -3, it will end up with 3. So at this point, complete the square. And to do that, for this term, half of -6 is 3. Then square that, that would be 9. So the same thing here. Get half of the second term. So half of 4 is 2. So square that, will end up with 4. So take note, we added 9 and we added 4 here. So to maintain equality, we'll do the same thing in the other side. So we will also add 9 and 4. So next to this, we will rewrite this to binomial form, in which we'll simply get its square root. So square root of x squared is x, square root of 9 is 3, and sign of the second term is negative. So the same thing here, square root of y squared is y, square root of 4 is 2, sign of the second term is positive. 3 plus 9 plus 4, we will end up with 16, in which we go back to the original given. So that's how are you going to transform from standard to general or general to standard. So let's have another example. So at this point, identify the center and the radius of the following. So at this point, this is a general form. So we need to rewrite this to standard form. So first thing, group all x terms and y terms. So there is no linear term for y, so just y squared. And transfer 7 to the other side would be negative 7. Now, get half of 8, which is 4. So square that. That would be 16. Then plus y squared. Then negative 7, we added 16, so also add 16 to the other side. So with this, rewrite this to binomial form. So square root of x squared is x, square root of 16 is 4, sign of the second term is negative, then y squared equals 9. So at this point, we can identify already the center, which is positive 4 and 0, while the radius is square root of 9, which is 3. Another example. Now, at this point, there is already a coefficient of x squared, in which it is 4. So at this point, we have to cancel or eliminate the coefficients of x squared and y squared. So to do that, we will divide the entire equations by 4. So with that, we will end up with x squared. We can cancel this. It's y squared. And 100 divided by 4, we will end up with 25. So at this point, we can identify the center, which is 0, 0, and of course the radius is 5. So take note, again, if there is a value of the coefficients of x squared and y squared, you have to eliminate that first, no? Before you can identify the center and the radius. Now, let's have a sample situational problem involving circles. So here, a street with 2 lanes, each 10 feet wide, goes through a semicircular tunnel with a radius of 12 feet. How high is the tunnel at the edge of each lane? So round off to 2 decimal places. So to do this, identify the given first. So in which we have 10 feet wide. We have a radius of 12. So let's sketch that. So sketching that, we will end up with this. Now take note. We have here a circular tunnel, semicircular tunnel, in which the radius is 12 feet. So from 0, this would be 12. So here from 0, it's also 12, and 0, it's also 12 here, or since it's going left, so negative 12. Now the 10 feet wide, so from the center to one end of the road, that's 10 feet. From the center to the other end of the road, it's also 10 feet. Now it is asked, at the edge of the tunnel, so how high, at the edge of the road, how high is the tunnel? So at this point, let's identify properties. The center here is 0, 0. And of course, the radius is 12. Another thing, the coordinate of this P here, so we move 10 here, then go up, and we don't know the value of the height, so that would be unknown. So given these properties, we can identify the equation in which it is x squared plus y squared equals 144, or that's 12 squared. Now using this coordinate 10 and y, this is x and this is y, so substitute. So that would be 10 squared plus y squared equals 144. Now 10 squared is 100. So transfer it to the other side, that would be minus 100. So with this, 144 minus 100 will end up with 44. Get the square root to both sides, so therefore we'll end up with square root of 44, or that is approximately 6.63 feet. So therefore, the tunnel is around 6.6 feet high at the edge of each lane. Next. Okay, so that's all about circles. Should you have questions, kindly post it in the comment section below. Thank you.